Something bright is already spreading around it before the image fully stabilizes.
Not behind it, around it. The center keeps vanishing inside its own atmosphere, while James Webb tracks the glow crossing black space. Frozen material this far from the sun should remain stable. Instead, the cloud keeps widening fast enough to hide the body producing it. And the closer the object moves towards sunlight, the less solid it looks. A probe would enter the debris long before it ever reached the nucleus. Dust first, then gas, then visibility failure. Astronomers attempt to isolate the solid center from the expanding cloud. Software filters the background light, searching for a stable edge, a fixed surface, anything that remains geometrically consistent between observation cycles. Instead, the pixels stay soft. The instruments can identify the gases. The body producing them still cannot be seen clearly. Solar heating makes the activity spread faster instead of stabilizing it. For a moment, the center almost disappears completely. Just a bright moving atmosphere crossing black space while something unseen keeps feeding it from inside. The cloud keeps widening while the object continues forward. But the tail no longer points where the motion says it should. For a few seconds, the entire shape looks physically wrong. A bright stream bends outward at an angle that makes the trajectory difficult to trust. The object appears to move one direction, while its visible material drifts another. The tail stops acting like a trail. A normal approach depends on orientation staying readable. Front, rear, direction of travel. But the gas spreading off 3-eye atlas keeps reshaping the image around the nucleus faster than the eye can stabilize it. The visible cloud now stretches across space thousands of times wider than the hidden body inside. And the brightest part is no longer the safest part to follow. A probe moving toward the glowing material could steer directly into expanding gas instead of the solid center. Dust impacts would begin early. Navigation cameras would start tracking the wrong structure. Small course corrections could drift wider with every second inside the plume. NASA tracking confirms the object is following a hyperbolic interstellar trajectory. It is not orbiting the sun like a normal comet. It is passing through once. The tail keeps bending anyway. The cloud stays easier to track than the nucleus inside it. The crooked tail remains visible for hours, while sunlight keeps sliding across the cloud. And for the first time, the behavior almost starts making sense. The bright side activates first. Gas pushes outward from the illuminated surface in uneven bursts before slowly twisting behind the object. The motion still looks unstable, but now there is a physical trigger attached to it. Sunlight is opening the object. James Webb Space Telescope detected a coma rich in carbon dioxide surrounding 3-eye atlas. Ancient frozen material is heating fast enough to erupt directly into space without ever becoming liquid. A body that may have remained dormant for billions of years suddenly starts venting the moment solar energy reaches the surface. For a while, the behavior starts looking physically readable again. Closer to the sun means more heating. More heating means more gas. The pressure should now follow distance in a predictable way. But surviving near it would still mean entering an active chemical storm. Dust would strike exposed surfaces continuously. Frosted material would coat optics and sensors. Tiny grains moving at extreme speed would scrape against suits, joints, antenna edges. The cloud keeps expanding, even while the object itself stays hidden somewhere inside it. A narrow line of sunlight cuts across the coma like a furnace door opening. Gas continues pouring from the lit side into empty space. The gas keeps venting from the sunlit side. Then different regions inside the cloud begin changing color. One region thickens while another fades.
Thin streams separate from the main coma like layers peeling apart inside the plume. The object still appears stable from a distance, yet the material surrounding it no longer behaves like one continuous atmosphere. The cloud is not one thing anymore. Observations around 3I Atlas began detecting different chemical signatures moving through the expanding gas. Carbon dioxide remains present, but now water-related material appears in parts of the coma. Cyanide signatures emerge. Nickel traces appear mixed into the outflow. The object keeps exposing different buried layers as sunlight reaches deeper into the surface. Each new release changes what survives inside the plume. Filters calibrated for one type of particle exposure could start clogging under another. Sensor readings would drift as reflective dust composition changes around the probe. Surface coating would build unevenly across optics and thermal panels. Even breathing systems inside a human suit would depend on predicting what enters the cloud next. But prediction is becoming weaker as activity increases. The coma continues glowing around the hidden center, while separate chemical regions drift through each other inside it. Telescopes can identify the gases. The body producing them still cannot be seen clearly. The separate chemical layers keep drifting outward long after the brightest activity peaks. And that is when the scale finally becomes obvious. The object is still changing while it is already leaving. 3I. Atlas does not slow down for observation. NASA tracking confirms the trajectory is hyperbolic. The object is not trapped by the sun. It is passing through the solar system once, carrying the active cloud with it back toward interstellar darkness. By the time the pattern becomes readable, the environment is already receding beyond practical reach. The coma fades slowly instead of shutting off. Thin gas continues venting into space, while the glowing cloud stretches farther from the hidden nucleus. From a distance, the body and the cloud begin merging together again, until the moving atmosphere becomes easier to detect than the object inside it. It leaves while still changing. Any probe attempting pursuit would spend most of the mission chasing an unstable chemical envelope through deep cold. Sampling systems would keep adapting to new material exposure, while the target itself continued shedding mass into the surrounding void. Entering the cloud would not guarantee reaching the center. Reaching the center would not guarantee leaving safely. And eventually, the light falls off enough that the details disappear first. The dim cloud keeps moving outward anyway.